Hi, this is going to be a short one today, just about 10 slides. Then you have some worksheets, and that's all I got for you. So let's start. Momentum. Momentum. Definition of momentum. Oh, by the way, I don't have any guided notes for you, so hope you got a piece of paper out. Momentum is the product, which means multiplying, of an object's mass and its velocity. Pause, write it down, come back. Boom. Alright. All moving objects have velocity and therefore a momentum. The higher the momentum, the harder it is to change an object's motion. So basically, momentum is a way of measuring how hard is it to make an object change its motion. You can have a really fast object, but it's tiny. It's hard to change its momentum. You can have a huge object that's slow. It's hard to change its momentum. How do I quantify how hard it is to change something's motion? There's an equation. There's always an equation. There's an equation. P equals mv. Actually, it's not a P. I know it looks like a P, like italicized P. It's supposed to be the Greek letter rho, but whatever. Lowercase p. I'll take it. Equals m times v. So lowercase p, Greek letter rho, is the momentum. That's the symbol for momentum. You already know what m and v are, mass and velocity. So there you go. Your worksheet's going to be using that equation over and over again, all right? Also using this concept, the law of conservation of momentum, states the momentum of an object will not change unless its mass, its velocity, or both change. Okay, so momentum is mass times velocity. If you're not changing the mass, you're not changing the velocity, you're not going to change the momentum. Oh, okay, duh. What about a system of objects, though? Systems of objects are objects that can interact with each other. So like the moon and Alpha Centauri, a star way out there somewhere, do not make a system. But the moon, the earth, and the sun, they make a system because they're interacting. They're not touching. Thank goodness, we'd be dead. But they do interact gravitationally. So they're a system. Does the law of conservation of momentum apply to systems? Yes, it does. You use it every time you go bowling, every time you play pool, or billiards, or whatever you call that thing with the felt table and the balls and everything. All right. So the law of conservation of momentum applies if all the objects in the system only exert forces on each other. All right. If any of them exert a force on something outside the system, you have momentum leaking outside the system, so it's not conserved anymore. Sadly, on the pool table, you have the felt table, and the pool balls do interact with the felt table. Friction slows them down. So not all momentum is conserved. But still, you can use this concept to play pool. So, we have two balls. Stop giggling. You know who you are. They interact with each other, which means they collide, so they are a system. You get with me so far? Alrighty. Law of conservation of momentum says that if I add the momentum of the two balls before they collide, and then add it after they collide, those two numbers will be the same number. Momentum of ball A plus momentum of ball B before the collision equals momentum of ball A plus momentum of ball B after the collision. They have to. And I'm basically saying it again here. In other words, add the momentum of ball 1 to ball 2 before the collision, then after the collision, it will be the same. All right. I have it in two different slides, two different ways. Okay, moving on. Of course, you can pause and write it down, then come back to me. There's that picture again, a little bit bigger this time. If you do one of them perfect little pull shots where this ball hits right here and sticks and loses all of its momentum, so it has to be a hard hit. If you ever play pool, you know what I'm talking about. Hit it hard and straight on, not a little bit off to the side, straight on. If you can manage that, then all the momentum goes from the cue ball to the yellow ball. And assuming the same mass, the velocity of the yellow ball will equal the velocity of the white ball before they hit. we were in class, I have a little lab for you to do with this. Sorry, we're not in class. Okay, assuming no external forces, momentum can neither be created nor destroyed. It can only be transferred. The conservation law. That's all the notes. There's the dark screen. All right, so